That's a huge motor, and it needs a giant exhaust system. And this time on Finnegan's Garage, I'm going to show you all the steps I'm going to take to build a badass set of turbo headers using cool stuff like this merge collector that I got from stainlessheaders.com. Check it out. It's time to get working on the boat, fellas and ladies, because summer is here already and this thing's nowhere near being completed. In case you're wondering, that's a fiberglass boat. And it was designed by a guy named Tom Peterson in Lake Havasu City. And it's called a Placecraft. And it's a little over 19 feet long. The hull weighs 420 pounds all by itself. And it's sitting on a stainless steel boat trailer that my buddy Matt Ringer built. And the boat trailer is actually on airbags. It's pretty sweet. It's got some mini truck styling. I like vintage, old looking stuff, so Tom built the boat for me with metal flake. Well, you know, it's got metal flake silver, orange, and blue, and it looks like hell inside the shop here, but outside in the sun, it's beautiful. It's a two-seater, just enough room for me and my wife, maybe the dog, and a cooler. And speaking of coolers, that is a Precision air-to-water intercooler sitting right there, right next to the dry sump tank, and that is 711 cubic inches of Sonny Leonard Hemi goodness. The cylinder heads are Hemi designed. He built them himself. They're cast aluminum. The cylinder block is cast aluminum as well. It was built by Brodix out of Arkansas, and it's a 5-inch bore space block with like an 11,200 deck height, so it's a monster engine. For comparison, the cylinder bores are 4.700 inches in diameter. The crankshaft has a 5.120 stroke. So do that kind of math in your head. It's giant compared to most everything else you've ever seen. And it didn't need to be that big. It's just a long story of how it ended up that big. Maybe I'll tell you guys that story later on. This is a jet boat, which is one of the least efficient means of propelling a boat across the water at high speed. Just ask a V-drive prop guy, he'll tell you that. But I really enjoy the challenge of making a jet boat go fast, because it's not easy. The way these work is that's basically a hole in the bottom of the boat, and there's a drive shaft coming out of the back of the motor going to the jet pump. The jet pump has a little impeller inside of it, kind of looks like a jet ski impeller, and it essentially sucks water out of that intake and squeezes it out of this jet pump. And it's interesting the way it works, because the water coming out of the jet pump, it doesn't have to hit something for the boat to go forward. It's literally the displacement of water from here to here is pulling the boat forward in the water. So if you were to point that nozzle straight up in the air, the boat would still go forward. It doesn't care. It wouldn't work very well. It wouldn't ride very good, but it would still work. So pretty sweet. So there's a lot left to do on this boat. Needs wiring, needs plumbing, but right now what it really needs is a set of turbo headers so that I can get that big hunk of the project done and get moving with the rest of it. So here we go. So in episode 2 of Finnegan's Garage, I was bitching to you about not having a proper vertical bandsaw. Well, looky, I finally have one. This is a Grob 4V24, 3 horsepower, 24-inch throat vertical bandsaw. I can cut almost anything with this. And the reason I wanted a giant saw like this was not just because I'm cutting stainless steel tubing to build headers, but because the throat is big enough where I can cut one-piece motor plates for mounting engines and drag boats and off-road cars and drag cars and stuff. So this thing's rad, and you're right now going to get to see how I got this beast through that garage door. It wasn't easy. No, I think you can buy them.
Okay.
How long have you had that one?
I just got it from a buddy of mine.
Does that have a rebel flag on? I'm gonna need counseling.
Thank you, sir.
And the rest of the Emory students.
Doesn't. Check it out. These are the major components of any header build that you're going to do. Except for this. That little guy right there, that is a T4 turbo exhaust inlet flange. That you won't have if you're building a set of headers for a naturally aspirated engine or supercharged. Cool part there. All of this stuff I got from stainlessheaders.com, and I can't say enough about that company because this stuff is made in America. It's real high quality tubing. They have a kick-ass series of videos on YouTube that'll teach you how to build headers. It's all laser cut parts. Stuff is just awesome. These are primary tubes. You can get them in J-bends or U-bends like I've got. This is 304 stainless. And the other grade of stainless you'll find usually in the automotive industry is 321. That's a better grade of stainless. You'll typically find it in aircraft applications. But if you can afford it, I say get that because the corrosion resistance is higher with 321. It's less prone to cracking under high heat circumstances, you know, in applications like turbochargers. If you got the bucks, buy it. This is a merge collector. It's a slightly different style collector than you usually see outside of a racing application. And the reason it's called a merge collector is if you look at all these primary tubes, they're cut at an angle. And they converge right there. Let's see if we can get enough light in there for you to see. See how they all come together? Nice point there. It looks like kind of like a pyramid. That's as good as it gets in terms of flow. And the merge point, you'll notice, chokes down right here. Okay? And in a lot of applications, there'll be a megaphone that expands right here, and that creates a venturi right here, which speeds up exhaust flow. Now, in a turbo deal like I'm building, you don't necessarily need to use merge collectors, but it doesn't hurt. It's very smooth, very good flowing collector design there. And to be honest, in a naturally aspirated application, a merge collector usually on the dyno will not show a power increase over a standard collector unless everything is right. The intake manifold, the cam, the collector length, primary tube diameters, all of that stuff has to work in concert for this thing to actually show a gain over a regular collector. They're very popular now. Lots of people are building them. They're slightly more expensive though, so if you're looking to save a few bucks, don't worry, you're not leaving 100 horsepower on the table by not using one of these. So there's the pieces. I'm gonna get cutting because I've got a lot of work ahead of me. Anytime I build headers, the first thing I like to do is figure out where the exhaust is going to exit, because there's only two ends to this. The end that attaches to the cylinder head, and that's a known quantity, you know where that's going to be. You know, there's our flange bolted up to our cylinder head. And the other end of it, the merge collector, is right there. Now, the boat, although it's wide open, it doesn't have a cover over the engine. It's a lot like a car in that there's not a lot of room to work with, and because this is a turbo header, it's going to get really hot. So the collector is situated halfway between the cylinder head and the gunnel of the boat, which this is fiberglass. This melts, burns, and catches on fire pretty easily. So in the end, no matter how good these turn out, I'll end up wrapping them to protect the boat. Ready? Time to cut stainless tubing. And that just gives me yet another opportunity to talk about my fabulous new to me saw. So this is a Grob vertical bandsaw. It's made in Wisconsin. I bought this used off Craigslist from a NASCAR shop in North Carolina that was closing up. And as they told me, everything's CNC, everything's computerized. They don't need old stuff like this anymore. Yeah. Because this is a $10,000 saw. If you buy it new, ask me how much I paid for it. $2,400. Telling you, Craigslist. So, 180 degree bend. These are awesome because you can cut it all over the place here and give yourself 90s, 45s. The only thing you can't do is make a cut that's not perpendicular to the tube. Because what happens if you do that is, if you cut it at like that angle, the tube's no longer around there, okay? So you gotta keep that in mind. Make straight cuts perpendicular to the tube, and you will always end up with mostly round tubing. Watch. Okay, so that was a 180 degree bend, and now I have two 90s basically. So if you see what I'm saying, that's a 90 degree cut to the bend, and it keeps this fairly round, okay? These tubes, they have a seam in them, so you're always gonna have a little bit of a flat spot there. But for the most part, these are round. Now watch what happens if I cut an extreme angle on this thing. This will no longer be round, and that's what you want to avoid. So see what happens when you cut an angle that's not perpendicular to the tube? That's no longer round. The way you can test that is that no longer fits together properly. See? That's what it should look like. So then you're asking yourself, well, how do I get all the different angles that I need? I'll show you after I answer my phone. Alright, so as I said before, you're saying, well, how do I get all the different angles I'm going to need, to snake these tubes where I want them to go? And you're going to get that every time you cut a 90-degree piece and you've got a leftover, save it. See all these different angles? These are round, but they're cut at slightly different angles. And so I can put them together to re-angle this tube in different directions. See that? Now there's systems out there that you can buy. Awesome systems for eliminating all of this scrap, or most of it. They basically look like Legos, but for tube bending and stuff. And they snap together and you can reorientate all the plastic pieces, and they're really cool. Ice Engine Works is one of them. I've used them before. They're bitchin', but they're expensive. If you're a shop and you're going to do this all the time, then yeah, that's a great idea. But if you're just doing one set of headers, order a couple extra bends, and as you start cutting, you're going to end up with extra sections of tube and extra little angled cut pieces, and you just save those, and as you're building, you just fit them together, look at them, change the jigsaw puzzle around, and eventually you'll end up with the tube you need, and then you move on to the next one. After the tube's been cut, you're going to want to dress up the cut. This needs a bevel on the edge before I can weld the other piece to it. But you may have to do a little tuning as well. Say this angle is just a little bit off. And you don't want to remove a bunch of material from the tube because it's just the right length. So the bandsaw is no good, the chop saw is no good. What we're going to work with now is the disc sander. This is a 12-inch disc sander that I bought at Harbor Freight. I think it's under $200 at Harbor Freight. You can spend a lot more on these. You can buy a Burr King. There's a bunch of other ones out there that are even bigger, like 24-inch models. And they're rad, but they're $2,000. So for this project, you can totally get by with a little 12-inch one from Harbor Freight. So to bevel the edge, all I'm going to do is fire that up and just lightly run the sounder on it. Now if I need to re-angle this and tune it up, all I do is set it down here, make sure my table is perpendicular to my sanding disc, and then let's say I need this re-angled this way. Well, I'm going to grind the bottom of it until the top meets the disc. Let's say that I need it angled this way. I'm going to grind the top until the bottom meets the disc. And all you do is go up in there and just push. You'll see it start glowing, and you can watch the spark pattern, and it'll tell you when you're there. So as the sparks get closer to the top, I know I've almost ground this until it's flat again from top to bottom. See? New angle. Now notice the heat line right there. It's thicker down here because that's where I started. I started grinding the bottom of this until the tube ran all the way into the disc and just barely touched the top, and that changed the angle of it. Now, heat is really important when it comes to stainless steel because this work hardens. It's one of the reasons I bought that Grob vertical bandsaw, because the blade speed is adjustable. You can slow it way down. You can't cut stainless at a really high rate of blade speed. So now this thing's pretty hot. I always keep a bucket of water nearby this thing because everything I work on down here is going to get hot. So we'll cool it off and then we'll move on to the next step of prep. It's sweaty in Georgia. Glasses are fogging up. We'll go to the spares. We'll go to the backups. This garage is air conditioned and it still gets sweaty in here. Alright, next step of tube prep. Grinding wheel, sanding wheel. Actually, this is a polishing wheel. I'm not going to use the grinding wheel because I don't want to take a bunch of material off of this because I've got to weld it. I don't want to make it too thin, so I'm going to use a buffing wheel just to knock the burr off the edge. And that's aggressive enough to put a slight bevel on the edge for me. Okay, now you look on the inside of the tube. We've got a burr all the way around. That's going to slow down exhaust flow. So, this handy dandy little tool, I was actually going to cut that out of there. And now it's smooth. There's other tools on the market that'll do that same job. There's these bitchin' ones. Where is it? Yeah, this thing. From DX Engineering. This thing's super cool. You can stick the cone part inside the tube when you have the right size one. Where'd the right size one go? Huh. Well, anyway, you get the point. There's a cone in there with blades. Shove the tube in there, spin it, and that'll deburr the inside of the tube. And then on this end, it's the reverse of that. Slide it over the tube, spin it, and that'll put a bevel on the outside of the tube. If I had the right one, I'd actually do it and show you. But it's gone wacky. Always loan your tools to the friends if you don't want to get them back in a timely manner. Alright. Last thing we need to do to prep this, actually there's two things left. If you look down in here, a whole lot of metal shavings are stuck in there, and they're stuck in grease. And that's because mandrel bent tubing is formed by sliding a mandrel inside of there, bending the tube around it. Well, that mandrel is greased so that it can slide through there smoothly. So that grease, that oil, whatever that is, has trapped all those metal shavings. We need to clean that out. A lot of ways you can do that. I usually just take a can of brake clean, spray it in there, wipe it out real good, and then when I get to the ends, I'll take some Scotch-Brite right where I'm going to weld on the inside and make sure I get that really clean. As this is stainless tubing, these are a really nice set of headers we're going to build. We're going to TIG weld these, and in TIG welding, you really can't have gaps between two pieces going together, and the tube has to be really clean, otherwise you're just going to blow holes in it. Same goes for MIG welding, but it's a lot more forgiving when you MIG weld stuff together. You can fill gaps as big as the Grand Canyon if you have to with a MIG welder. Okay. Alright, and the very last thing we're going to do before we weld this stuff together is we're going to clean the outside of the tube. Now, stainless polishes up real nice. I usually don't polish this stuff, but I Scotch-Brite it to get all the names and numbers off and the lines in the tubing just because it looks better. Now's the time to do that, because if you weld this all together, you're never going to get into the inside of all these bends to finish it. Here's the part where this gets turned into some sort of meme on the internet. That doesn't look good at all, does it? Mike's just rubbing his pipe. Okay, here's something you should know. From time to time, you're going to get a tube that after you cut it is going to have a kink in it. You know, sometimes in more than one place. Don't worry about it, especially if you've worked on this tube and it's exactly what you need. You can always fix this. What I like to do, see there's a flat spot there? Just put it down here on something soft that'll keep the tube from getting damaged. Take a ball peen hammer. Just tap it. See, it's getting round already. Needs a little more right there. And then, these parts where it's bulged out there and there, you can stick that in a vise, and be sure to tape the jaws of the vise so they don't mark the tube, and you can squeeze that in. You can either do that now, or you can do it when you're welding two tubes together. I like to get it as close to round as I can before I start, and then set the other tube on there, and then use vise clamps, and just squeeze it just a little bit before I weld it, just so I can get as good as a fit as I can. Okay, I got my collector where I want it. I've cut a piece of tubing. I've fit it to the header flange, you know, just loosely, so that I can kind of eyeball this whole thing and figure out, am I headed in the right direction? Can I make this tube meet up with the collector in a manner that looks good, that flows good, all of that. And once I'm satisfied with that, I'm going to tack it to the flange. You'll see I've already done that here. And I'm not going to finish weld this for quite a while. There's a lot of work left to do. Most importantly, you'll notice that round tube, even though I've crushed it into an oval shape, does not even remotely fit this header flange. And it's not because the flange is wrong. It's just that the flange is cut to be slightly larger than the exhaust port of the cylinder head. And the tube is round. And so there's nothing wrong with this. All that's going to happen is I'm not going to fill a massive gap here with weld. I'm actually going to heat and bend this tubing to fit the flange so that when it's done, I've got a nice, easy weld to make there, and one that's less prone to cracking and leaking and all that. So don't worry, this will be all good. Now I like to start with the port closest to where the collector is, because that's usually going to result in your tightest bend, and then I build around that. So as you can see, this is the driver's side of the motor, this This is port number 7, and that's, you know, a fairly tight bend going right up into the collector. There's one pipe right here that I cut and twisted so that this tube curves backwards and then kicks up just a little bit to get me the angle I need. And then that's just a straight piece going right in there into the double slip joint. Once I've got that one, I go to the one below it. That one here is just a straight piece with a little 30-degree curve on the end of it. And that one, I'm just gonna snake right underneath here up to that one. And then I'm gonna move over and do the same thing here and then the same thing here. Now, none of these pieces are gonna be equal length, not even close to it. But in a turbo application, it really doesn't matter. Your only concern here is that the expansion rate of all these tubes is gonna be different. And we'll address that later on, but in the end, to keep this thing from cracking, we're gonna tab 2 of the tubes, one on each side of the collector, and that should make this thing last pretty long before it just decides to start failing. Because everything expands at a different rate, but everything's gonna be solid back here. You know, the turbos will be attached here, and then there will be a brace connecting the turbos to the engine plates. At some point, all the heat cycles are gonna catch up with this thing. But we're going to make it last as long as we can here by building a little bit of flex into the system. Although the header flanges come as one unit, I'm not going to leave them that way. Because I know that if I cut these into separate pieces, I'll have a much easier time of welding all the primary tubes fully around, and I can disassemble the headers later on if I want. Scotch-Brite them, polish them, whatever, you know, bling them out. So right now I'm going to use a death wheel, and I'm going to eliminate all that separation anxiety we've got going on over here. And it is a death wheel, they call it that for a reason, so note the safety. 2 layers of face protection. And I'm trying to make this whole thing look spectacular. So after I've cut all this stuff, I'm going to dress up the edge of this because, I mean, these were beautiful laser cut flanges, so let's keep them looking proper. Header building requires 2 phases of welding, and the first phase is purely for mock-up. So what we've got here are 2 pieces of tube that are going to make up part of my primary tube, and I believe this is the right shape I need, but I need to confirm that. And what I'll do sometimes is wrap electrical tape, or more often than not, painter's tape around the joint, hold it up in there with a couple more pieces and make sure it's in the ballpark of what I need. But really, the only way you're going to know is to weld this stuff together. And right now we're going to tack it together. So you'll notice the tubes fit tight. There's no gap there, which is important. There's a beveled edge on each tube. And we're TIG welding, so no gaps. That's rule number 1. Rule number 2, tube needs to be clean, both inside and out. This is stainless tubing, so when we go to final weld it, we're actually going to back purge the inside of the tube with pure argon. And the reason you have to do that is stainless is a reactive metal, so you need all of the impurities that are in the air, in the oxygen, gone from the backside of the tube. Otherwise it crystallizes and it's really not a good weld. So right now our tubes are ready. We're going to get our welder ready. And my personal rig is a Miller Electric Dynasty 280DX, which is a fantastic welder. It's an inverter machine, so it's small. This has the optional coolant pump on it, so my torch stays relatively cold no matter how long I'm welding. Right now we're set on DC. We're at 110 amps. This tube is about 67 thousandths thick, so really we only need about 70 amps to weld, but I usually give myself a little extra room, and it's adjustable right there. I love this welder because it's so flexible in terms of the output, you know, how long You can pre and post flow the gas, what the startup looks like, everything about it really nice, and it will weld really thick metal. It's 280 amp machine, so I dig it. So let's get to tacking. Time to tack weld. Here's my setup. It's a Miller electric torch. I've got a long cap on the back, and that's just because right now I've got a long piece of tungsten in there that I didn't feel like shortening. Doesn't matter. That's not a stock cup. This is from a guy named Michael Furyk, who I met through Instagram, and he makes these oversized cups that work really well. The gas coverage is really impressive. You have to use a little more argon. You know, you'll run a little more cubic feet per hour, but it works really well. And you can stick the tungsten out much further than you could with a smaller, like number 5 or 7 cup. I think this is a number 12. You might call it the FUPA. I'm not going to explain what that is, but FUPA. You'll figure it out. So notice, no filler rod. Sorry. Notice there's no filler rod. There's no gap here. So in theory, I should be able to just fuse these two pieces together if I do this correctly. And if you can hear it, the argon's still flowing and cooling the weld. That's the post flow of the welder. It's a timed sequence. You can set it up to flow as long as you want or as little as you want. Alright, so we have a good tack there. Because all the heat was concentrated to this side, it started lifting this side of the tube. So I'm going to push down on the top of it and get the tube back together, and then I'm going to tack this side. And I'll put 3 tacks on this. 2 will do the job, but if you have to do any kind of tugging or pulling to get the tube back in the header, 2 tacks might not hold. So we'll do 3 here. Turn this around and we'll do one more. Now that it's tacked together, I can set it on the bench and I can get my food back. Just fuse this together, because if this is wrong I need to take it back apart. It's much easier to take it back apart when you haven't stuck a bunch of filler rod in there. And the other reason is that I'm not back purging this, so if I was to stick a lot of heat in there, you'll see on the back side of the tube that it's crystallized and it's not a great weld. So fuse it together, make sure it fits. When you're confident it fits, come back on the table and then back purge this tube while you finish weld it. And we'll get into that a little more later. Looks pretty good. All these lines mean something. And the reason they're there is, as I was building the headers and working with the jigsaw puzzle the pieces, you notice there's a lot of pie cuts here to make corners. I marked them when I thought I was ready to weld them. So what I would do is get the pieces fit together, take a Sharpie, put 2 or 3 lines on it, and that tells me when I take this back over to the bench where to orientate everything to make sure it's lined up properly, so that after I tack weld it and I bring it back here, it drops right back into place and everything fits. Doesn't sound right. It doesn't sound right because I'm running out of argon. Okay, well, that'll be a quick end to this video. Yeah, the headers are all tacked together. I've begun welding them, but I just ran out of argon, so I can't back purge. So that'll be the end of this video. Tune in probably weeks from now when I get a new argon bottle, finish welding all of these, and mount the turbos. I'll see you next week.